Independent events. In this module, you will learn about independent events. Suppose you roll a dice twice. The outcome obtained on a dice in its first throw does not depend on the outcome obtained in the second throw of the dice and vice versa. Thus, the events getting a 6 in the first throw and getting a 4 in the second throw are independent of each other. Such events where the occurrence of one event does not affect the probability of the occurrence of the other are called independent events. Now, consider a bag containing 4 red and 3 green balls. If we draw one ball at random and put it aside, and then we draw another ball from the bag, the probability of drawing a red ball the second time depends upon the result of the first draw. If the first ball drawn is red, then the probability of drawing a red ball second time is 1 upon 2. On the contrary, if the first ball drawn is green, then the probability of drawing a red ball the second time is 2 upon 3. Thus, the events drawing a red ball in the first attempt and drawing a second red ball without replacement are two dependent events because the occurrence of the first event affects the probability of the occurrence of the second event. If the first ball drawn is put back into the bag, then the probability of drawing a red ball in the second draw is same as the probability of drawing a red ball in the first draw. In this case, the result of the second draw after replacement does not depend on the result of the first draw. Thus, the two events drawing a red ball in the first draw and drawing a second red ball with replacement are events such that the probability of occurrence of one event is not affected by the occurrence of the other, that is, they are independent events. Now, let's study some more facts about independent events. Consider an experiment of drawing a card from a deck of 52 playing cards. If A and B denote the events, the card drawn is a diamond and the card drawn is a king respectively, then the probability of event A is 1 upon 4 and the probability of B is 1 upon 13. Now, consider an event A and B that denotes the card drawn is the king of diamond. Since there is only one outcome favorable to the event A and B, out of total 52 outcomes, probability of A and B is 1 upon 52. Now, applying the concept of conditional probability, the probability of an event A when another event B has already occurred, that is, card drawn is diamond when a king has already been drawn, is equal to the probability of A and B upon probability of B, which is equal to 1 upon 4, which is same as the probability of event A. These facts help you conclude that the occurrence of event B has not affected the occurrence of the event A. Similarly, the probability of an event B when A has already occurred, that is, card drawn is king when a diamond has already been drawn, is equal to 1 upon 13, that is, probability of event B. This indicates that the occurrence of event A has not affected the occurrence of event B. Thus, events A and B are independent events. The earlier discussion helps you define the independent events other way also. Two events A and B are said to be independent if the probability of the event A when the event B has already occurred is equal to the probability of A, provided that the probability of the event B is not equal to 0. Also, two events A and B are said to be independent if the probability of the event B when the event A has already occurred is equal to the probability of the event B, provided that the probability of the event A is not equal to 0. Now, applying multiplication rule of probability, probability of event A and B is equal to the probability of event A into the probability of event B when the event A has already occurred, which is further equal to probability of the event B into the probability of the event A when the event B has already occurred. Since for independent events, probability of A when B has already occurred is equal to probability of A, and probability of B when A has already occurred is equal to probability of B. This helps us to conclude that if A and B are two independent events, then probability of A and B is equal to probability of A into probability of B. In this module, you've learned that if A and B are two events such that the occurrence of one event does not affect the probability of occurrence of the other, then the events are called independent events. Two events A and B are said to be independent if the probability of an event A when B has already occurred is equal to probability of A, provided that probability of B is not equal to 0, and probability of an event B when A has already occurred is equal to probability of B, provided that probability of A is not equal to 0. If A and B are two independent events, then probability of A and B is equal to probability of A into probability of B.